Welcome everyone to more open source work here. So running yesterday's live stream there on the main channel with AMD's Zen for AVX-512 adoption. I found here this because I mentioned JSON parsing and cryptography and stuff, and I found here this simdjson, which is open source and amazing. And just to illustrate, up to 4 times faster, not sure if that includes AVX-512, but at least previous AVX implementation. And this is also the creativity, right? It is of course meant for multimedia data, at least in the 90s, the MMX3 now, SSE, even also internet streaming extension or whatever, right? But you can of course accelerate everything where you pack multiple data bits and pieces and slices at a time, shuffle them around and stuff, compare them. So yeah, you can process pixels and you can process ASCII data. You can even, obviously, previous video also accelerate good old-fashioned memcopy and stuff, stringling and so on. So that's so just people also wonder that Intel doesn't have a better overview here. I would expect here some really nice presentation, but yeah, how this relates to, I don't know, this is a sad thing that big tech doesn't have a nice overview. If you take a look here, how does this implementation look? We will also package this in a moment. Here's, by the way, some benchmarking, so that would be blocks, bytes. Just as we start, is it here? Special block something, a little bit 100% compared to what? Is it runtime or what is it? Speed, all stages. Massive, reduce the number of instructions. To lesser extent, reduce the number of cycles. However, we have to run significant low frequency, like previous video, right? Intel boosting less frequency, throttling is overall slower. Results may vary per processor. More latest processors, Rocket Lake, Ice Lake, less affected frequency throttling. I'm actually wanted to see the diff. This is PR with a small change, likely. It's likely that the results P of by default due to frequency throttling. Yeah, we will be curious to see how much AMD is affected. So results, Rocket Lake, most recent. Do we have here some summaries? So that's promising. Demand. And also benchmarking, right? If you just implement stuff and you think it must be faster, it often is that it's slower, right? Benchmarking, and no premature optimizations. I actually wanted to see, where is the commit, something. Runtime dispatch, implementation of operator. Let's see if that is the main commit, just to get an overview how the code might look like. Okay, yes, some SMD. Load full diff. Wish there would be some load me all of the diffs that I don't need to be so careful scrolling over that. So lots of the stuff is also dispatching. CPU ID bits, as we've seen yesterday, those, hey, they have freaking AVX acceleration. Freaking kidding me. Or not, no, alt, is that x86? AVX, interesting. Our PowerPC stuff is already DOM parser implementation, so here probably comes interesting stuff. Also, yeah, C++, right? Not that, I mean, could not write more readable code. What do we have here? Max array. Not the most. How does it work algorithmically? Does not look somehow. How does it work? So maybe this is some checking for quotes and backslashes, one whole 512-bit vector at a time or so. I wish it would be more obvious here. Some 16 values as many times as necessary usually for lookup tables. I would have hoped the code would look more interesting, to be honest. Anyway, let's package that. I grabbed our reference build test data just a minute ago, and no log contains checking for this SIMD JSON package. Some Linux distribution have the package for that already, but it looks like none of the packages in the T2 package repositories does make use of that yet. Some nice update there. So what I usually do is, so we probably, this was data. So what I usually do for commits like that is check if they are marked odd stable. So for data to have a chance to, this is odd stable, why does it not? It's maybe some custom Git web frontend. That is probably why. So then that's certainly text process. Let's create a package. Do we have other SIMD stuff? No. And one thing I should say before people tune out here, just packaging that, I wish we would have compiler technology. I mean, we have some auto-vectorization, but somehow it should also not be, in my opinion, in my experience, that we need to hand write this code. Somehow I would wish we would have had such a state of compiler advancement, also not maybe less imperative programming languages, even more advanced than Rust, so that you would more formally think mathematic formulas, write down the actual, like, not imperative top-down, top-bottom code, how like if then else, how we program this, but more algorithmic, more algorithms, more conceptual, like I want like math formulas, like for all of this text and stuff, for more advanced compilers and language setups to generate that. But yeah, because somehow it doesn't scale that we hand manually write either with compiler macros or function glue, just reusing that, or even true good old-fashioned manual written in assembly. Somehow it certainly doesn't scale, because otherwise, why does it not scale? Because you need to, someone needs to do that, and this is even funded by some government funds here, some Canadian or so, and sometimes the US also funds stuff, or in the EU, and they also see that nobody before has done that, and so that required some Natural Science Engineering Research Council of Canada, another grant to fund that. And as per usual, even other stuff, right? Think FFmpeg and other Wayland and Xorg stuff, someone needs to do that. Do we have no other JSON? And this is everything that needs manual labor, of course, is less used. So on top of auto-vectorization, some more intelligent code generation would really be favorable. But that is the thing, people always think, also Intel and Apple and Google, everyone thinks they are so smart, and yet they all cook with water and have less than stellar and peak bugs solutions and bugs and features. So what I usually don't do is copy this like advertising stuff very honestly. Yeah. Micro parallel algorithms. Yeah, the thing is, of course, as seen here, even in their benchmarks, if some little code uses that, Intel CPUs already throttle down and boost less, so that is, of course, but you still have, I mean, AVX-512 is new there, so you still have JSON for. Is that their best summary they can? I mean, we could include that slogan if we wanted to. Just so people find it better. Do they have, hey, they have a website. Yay. Maybe I should have included something. Yeah, maybe we should take a closer look at the algorithms. I really would like to take a look there. Even they have publications. Maybe they have a nice paper here actually. Yeah, okay, let's package it first and then. Oops. Why do they upload an H and CPP file? Funny people. Cross, hopefully that was Apache. I think it was APR. So what was the syntax? Was it like that? Man, one day I need to remember it. So authors. Here we have some. I mean, we can give them, for their amazing achievement, give them 3 lines here. So then let's see the downloads and builds. Welcome everyone. Okay, that did not download. So GitHub, something archive. Did we not have this? What is the tag name? Packages? Yeah. What are their tag names? They have tag names with. Does that load tag? Or does this? No, I think this was Erlund. Man, I saw it when the stuff doesn't just download. Archive version, what do I do differently there? Archive version, do I do it like that? Maybe best with our check find it. Maybe that is better. Yes, it is. Of course, such a thing is only beneficial if you parse gigabyte of JSON stuff like in your servers, and it's like one client call of parsing time, a little bit of JSON. But this probably, and it just built, let's maybe double check that it installed correctly. Like if we would have like more foundational libraries, is it even fully installed correctly by default? We should only have like one really good reference library, or I mean, sure, people can do their hobby stuff, but we should have like how we had it decades ago, like one libtiff, one libjpeg, one libsetlib. Nowadays we have for each thing a dozen libraries, and each one only does one thing well. That is a little bit of a problem in open source land, in my opinion. But share, like, and subscribe, and leave a comment if you agree or disagree. Need to edit that a little bit, just in case, because there's some. Does it use boost? Or maybe it does. Why is there some? Okay, it does not look. Yeah, this is why we sometimes have stray dependencies. We need to get better at that, to be honest. So there we have it. Another nice, amazing new package. Does it cross-compile? Oh, maybe it does. We can probably commit it like that. Actually, I made a mistake. I shouldn't have copied that. Now our diff is literally larger. Something of that sort, right? Actually, wait a second. Now that we don't need a little bit last minute polishing. If we have this title already, I think there is again some crumb in this membrane keyword. Maybe I shouldn't use a 25-year-old some membrane keyword. The down arrow does not work. Maybe because sometimes I shake the dust a little bit out. Maybe that is not the best thing to do, because I had this already. Maybe now the second time that some dust or stuff, crumb, moves behind the membrane. So yeah, there we have that. That probably should be fine. I'm a little bit tempted to look a little bit at this implementation, like the last 5 minutes. I'm always curious to learn something, although that or learning from these papers. Where do they have? So yeah, they have PowerPC. I mean, funny that they have PowerPC but not ARM. By the way, not the greatest fan of this Haswell and stuff, because I would so name this SSE or AVX or stuff, but so yeah, the stuff is actually pretty small, I think, at least. Maybe we should take a better look at the publications. Taming branches. Here's some 2019. What do we have there? It's probably an early version of that, I guess. Fast JSON parser. So why it is fast? It's pretty fast, 2 to 3 times faster. Difference between that is stage 1, part of the system that detects the location of structural and pseudo-structural characters from the input. The system operates with large-scale and regular operations over 64 bytes of data, as I outlined earlier. Can take advantage of both SIMD, 64-bit or larger wide. Mask obtains from masks obtained by SMD operations. For example, input consists of sections comparing two keys and value pairs. Enters and leaves the condition of being a string 4 times in under 64 characters, a loop which invokes step-by-step scanning of the input, typically not beneficial from SIMD due to relatively short strings, and will need to perform a relatively slow operation detecting the next string. By contrast, their stage 1 code, right? I guess it's a 1. Would detect all strings beginning and end markers with fixed cost set of operation or by admittedly complex set. Further, the code without data-dependent conditional branches bring pipeline to a crashing halt. How it works. So yeah, extremely little code. Let's maybe how it works. Let's read this maybe. Soviet era joke. Four stages, measure up, something. Stage 1 uses SMD to discover the significant parts of the document that need to be fed into the parser, which is step 2's job. Stage 1 is not necessary to validate what happens. Instead, stage 1 is to expose what stage 2 needs to see. So we need to build a set of structural characters such as braces, commas, and colons, that stuff. Potential items such as true, false, null, and the numbers. I really would like to do, maybe we'll continue with code generation. I already started RISC-V stuff. And I really think, as I mentioned already in the beginning of this live stream, we really need languages and to more automatically, generically generate or recognize and implement such stuff. UTF-8 Unicode checking. So what this means is, because UTF-8 has this variable length encoding, validating, for example, that this is not too long. Like think, what is the maximum? Usually 4 bytes, I guess. You need to read the spec, unless I extended that. But like that, you don't have like infinite amounts of variable lengths. Highest, most significant bit set prefixes there, or in general also validating the Unicode ranges potentially. Odd length sequences of backslashes would result in escaping, so basically escape checking. Detecting which characters are inside quotes by filtering out escape quotes characters from the previous step. Probably a prefix sum over X or using the PC. So these are complex interlength instructions. The right instruction is an argument of -1 as a multiplier to turn there escaped quote mask into mask showing which bits are between the pairs and quotes. So yeah, similar to what I expected, similar how I outlined that. I've seen similar things with string links and string copy, and yeah, interesting stuff. Also interesting that they have AltiVec, so that I guess, wait a second, was this AltiVec? No, this was as well. Yeah, my pro tip names this stuff for, like, who knows now what. So I was like this AVX, I mean, why not name this AVX? Why not name the AVX-512? Why not name this AVX, I don't know what, 2 or so? Because that is a thing, right? Even, wait a second, they have ARM actually. Earlier I said they don't have ARM. No, I only realized, no, somehow I read this is AMD 64. So yeah, there's ARM when I was wondering. They have that. I mean, it's extremely little code, right? It's crazy that. It's crazy how, I mean, okay, they have more header files though, who knows what they, I mean, and so on. I mean, they fussed that, oops. But this is, just as I usually say, is a surrounding work of having that release quality documented. Not the biggest of all libraries, nonetheless interesting. And this small, people always ask me what they should do. Do what interests you, what you need, or other small things like this where you can learn something from. And people think you can't write high performance code in C++, right? Although I would argue it might not be the... Yeah, but if you want to get into C++ code because it's at least better than C, then here is some small code. Where's the AltiVec stuff here? Oh, there's some SIMD vector here, SIMD AVX-64 or 8x64. Look up there. Yeah, but this is also how you write code, right, Rick? With just some 10 minutes of trying to understand this, with such kind of also C++, little bit of sugar coating this stuff here, and not like open coded, like look at all the C projects of macros and open coded strings and stuff. So yeah, interesting stuff. I hope you learned something. We probably can drop the URL, actually, you know what, let's use that one here into the chat. I hope you found this useful. T2 has one more package. I would think that it builds for all architectures. We could actually theoretically test that. You know what, let's do a little bit of extra work and try the cross compilation. What did we have? 22.5. Let's see what happens if we like risk 564, which doesn't have a vector extension yet. Let's see what happens. Best without typo. But I would think they have a generic implementation to have a drop-in API for all other platforms as well. So that would probably be this generic or fallback or stuff. Here's also, I just saw, okay, here's some more algorithms and we committed here. Good that we checked that, because This was 0, 1, 2, 3, 4. So yeah, even fonts. This had more markings because we need libxml or whatever we copied there as a bootstrap. So yeah, that also apparently builds for and cross builds and cross installs. And let's double check that as well. Here's a pity is that actually we use so yeah, as this worked, I guess that should be RISC-V. Let's see. Oh no, that also works. Interesting. Why does this not? But we can check the log. I mean, we could extract the archive in object dump. Oh, wait a second, does object dump directly? Don't do that stuff on a daily basis. Yeah, that F64 little RISC-V. Okay. Good. That correctly cross-built. Then should have checked this. But yeah, this is kind of stuff, even if I would have done it without YouTube, I probably would have overlooked this. I need to remember to better copy more generic packages. But yeah, this is why, even in Git pull requests, you sometimes have like refined stuff and like fix some typo and stuff. But anyway, hope you learned something and found it interesting. Don't forget to like, subscribe, and hope to see you soon for more such fun stuff to come.